Hey guys, welcome back. Okay, we are picking back up with the lesson that we quit halfway because it took me so long to teach the first half. So this is all about the translations, the transformations. This works just like all the other ones that have the H and K. H is your horizontal shift and K is your vertical shift. Okay, so the horizontal shift deals with right and left. So right, you'll know it's moving to the right if you see a minus because your equation has minus h, so that would be a positive number. And then if it changes to plus, that would be minus a negative, so it would actually be a plus sign, so that would be left. Your vertical shift is your up and down. You know it's up if it's plus, just like normal, and down if it's minus. That's what we'll be using for today's lesson. Okay? All right, so let's do it. Remember that when you do this, the first thing you have to do is make the table for the exponential. So this would be 4 to the x power equals y. Okay, so we would make our initial table. -2, -1, 0, 1, and 2. I'm going to do this quickly. I think you got this from last lesson. If not, go back and watch the previous lesson. You're just doing 4 to each power. This would be 1/16, 1/4, 1/416. Then, to get the log, you have to take the inverse, which just means I have to flip the table. Let me get a different color. So this is my inverse. 1/16, -2. 1/4, -1. 0, 1, 2, 1/416. Okay, you have to do that first. This is the log. Okay, this is what we do to get the log. Okay, now that we have the log, this is the parent function, but this has a shift. It has a -1 in parentheses, which means it's the horizontal shift. Now, it's a -1, which means that we are actually going to go right 1. So since we're going right 1, you're taking all of your x values and you're going right 1. Well, that's a positive move. So my new table, the y values are going to stay the same. Nothing happened with our up and down. Your x's are going to increase 1 because you're going to the right. So that's going to be 1 and 1/16, 1 and 1/4, 2, 5, 17. These stay the same. There is your final draft. That's the final equation. That includes the -1. So then you would just plot it. Okay, so we've got 1 and 1/16. So that's going to be very close to 1 and then down to -2. So not on 1, but pretty close as we can get. 1 and 1/4, -1. Same thing, really close to that. 2, 0. 5, 1. So 2, 3, 4, 5, 1. And 17, 2 is off the graph, so I'm not going to worry about it. But what you can see is that because we shifted to the right, our asymptote, also shifted with us. So now your asymptote, instead of being at 0, the y-axis, your asymptote has shifted and is there. So that's my new asymptote. It is a vertical line. Since it is a vertical line, it is going to be x equals 1. That's your asymptote. I just answered that for us. I hope that uploaded that video. Yeah, it did. Okay, cool. So we've got our asymptote there. Now, we can work backwards. The x-intercept is very easy. It crosses there at 2, 0. We got that. Let's go back up here. So our domain and range. Now, if we look at the ones on our previous lesson, that's the wrong one. Hold on. what to do with it. Here it is. If we look at this previous lesson, your domain and range was all the x's that are greater than 0. This is all the x's that are greater than 0. So those were the same, but their asymptote was at 0. This one is not. So since this one is not and has been shifted, that's going to change our domain. Our domain will now be all the x's that are greater than 1, because that's where our asymptote is. We're not getting over there to 0. Again, it's not equal to 1 because this was 1 and 1/16, 1 and 1/4. So it's close to 1 but not touching 1. Okay? Your range, though, is still going to be everybody. We're going down, down, down to negative infinity, and this is going to continue to increase up, going up. So it's going from negative infinity to positive infinity. In behavior, okay? If we look at the end behavior of these, this one was growth. So we were going as x equals, sorry, something on the news came on, I got distracted. But you can see that this one had growth. Okay, so since this one has the growth, it's going to match this one. It's still going to be the same. It has nothing to do really with the asymptote for this one. So here we are. As x approaches infinity, y is approaching infinity. So as we're going this way, we're growing positively. Now for this one, as x approaches, this is where your asymptote comes into play. As x approaches 1, your y approaches negative infinity. So that changes because it's no longer at 0, it's at 1. So what have we learned from this problem? What we've learned is that if we have a horizontal shift, our asymptote is going to change with that horizontal shift. This one was right 1, which is why you see it here moving right 1. If we look down the page, this one is plus 9 inside the parentheses. This is minus 2, but it's not inside the parentheses. So since it's not inside the parentheses, it's not horizontal. It has to be inside the parentheses to be horizontal. So this one is plus 9, which means its horizontal shift is going to be to the left 9. So since it's going to be to the left 9, I can go ahead and go to the left 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There is my asymptote. I am able to do that just by knowing that that is my horizontal shift. The one at the bottom of the page, this one is a negative 2 inside the parentheses, so that's my horizontal shift. So, since that's my horizontal shift, which direction am I going? I'm going to the right. That's correct. Going to the right. How many units? 2. Very good. So I'm going to the right 2 units, which means this is where my asymptote would be located. So for number 5, my asymptote is going to be at x equals negative 9, and this one is going to be at x equals positive 2. Okay, so that's what controls your asymptote. Does that make sense? If not, rewind and watch it again. Okay, back to number 4. So if we look at number 4, this one is again not in parentheses, which means it is a vertical shift. So it starts the same way. We start with our base, which is 3 to the x power equals y. This is exponential. This is not my logarithmic. It's just what I'm using to get a table. There you go. Then you plug it in. 3 to the negative 2 is 1/9. 3 to the negative 1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. 3 to the first is 3. 3 to the second is 9. Beautiful. Exponential. Now you need to do the, you got it, the inverse. Okay? So for my inverse, I'm just going to take that table and swap it around. So this is going to be 1/9, 1/3, 1, 3, 9. All of the y's became the x's. Now my x's become the y's. Negative 2, negative 1, 0, 1, and 2. Bingo. From there, I'm going to apply the shift. This is outside of the parentheses. There's not a parentheses, so my x's are going to stay the same. 1/9, 1/3, 1, 3, 9. No change. The 2 is on the outside of the parentheses. What is happening is it is going down 2. Okay, because it's negative, which means down. It's not opposite. It's not like H. K does what it says. So since that is -2, we're going down 2. So I'm going to take the previous y and I'm going to subtract 2. -2 minus 2 is -4. -1 minus 2 is -3. 0 minus 2 is -2. 1 minus 2 is -1. And 2 minus 2 is 0. Voila, there you go, plot your points. So 1/9 is very close to 0 at -4. Okay, then we have 1/3, and that is at -3. So again, very close to 0. 1, -2. Then we have 3, -1. And we have 9. Did I mess something up? Oh, I did. Look. This is at 2. That's in the wrong spot. So, I think I have white out. Let me fix that for us. Whoops. Well, sorry, y'all. Fast forward that part. Okay, so then we have 3, -1. So that's 1, 2, 3, -1. That's in the right spot. And then we have 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we still have our shape that curves. The asymptote has not shifted, so it's at 0, and that's going that direction. Sense? Okay, let's talk about all our parts. Our domain and range. So our domain is going to be all the x's that are greater than 0 because my asymptote is at 0. So I'm just going to go ahead and say x equals 0 for my asymptote. My range hasn't changed. -infinity to +infinity. The end behavior as x approaches +infinity, y approaches +infinity. As x approaches 0, that's a 0, y approaches -infinity. Perfect. Okay, now for my next one, okay, we can look at this. You can see that we have 1/2 as our base. That does not change anything. It's still going to continue to be exactly the same. We're going to have 1/2 to the x power equals y. Let me go back to this brown pen for my first one. Just like normal. So -2, -1, 0, 1, and 2. Everything's the same. We have 1/2 to the -2 power. What that's going to do is it's going to take your fraction, it's going to flip it because of the negative, so you'll have 2/1, and then that 2 will be to the second power, so it's actually going to be 4. Now, you don't have to do that in your head. You can use a calculator. So, clear, that would be fraction 1/2. Raise that to the -2 power, and it gives you 4. But if you want to do that mentally, what you're doing is you're taking that 1/2 and you're taking the reciprocal, flip it, 2/1, and then 2 will be to the second power. So this one would be 1/2 to the -1 power. Flip it, that would be 2/1. 2 to the first power is 2. Then we have anything to the 0 power is 1. 1/2 to the first power is 1/2. 1/2 to the second power is 1/4. If you don't know how to do those, use a calculator. All right, then you're going to do your inverse. The inverse is just going to be the flip of those. So your x's become 4, 2, 1, 1/2, 1/4. And your y's are -2, -1, 0, 1, and 2. Now we need to apply our shift. So the x is going to decrease 9. It's opposite than what it appears. It's going to the left 9. And your y value is going to go up 4. So that just takes your table and moves it both ways. So we do 4 minus 9. That's negative 5. 2 minus 9 is negative, hold on, let me make sure I do this right. I don't want to mess this up. 4 minus 9 is negative 5. I did that right. And then 2 minus 9 is negative 7. That's what I was going to say, but I was doubting myself. 1 minus 9 is negative 8. 1/2 minus 9. Let's put that in the calculator. 1/2 minus 9 is negative 17 halves. As a mixed number, that would be what? What's 17 divided by 2? That would be 8.5. Let's just use the decimal. Let's save ourselves the trouble. Negative 8.5, and then this one would be negative 8.25. Okay, perfect. Then our y's are going to add 4. So we've got negative 2 plus 4, so that's going to be positive 2. Negative 1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. And 2 plus 4 is 6. Then you would plot that. Okay, so we've got negative 5. 1, 2, 3, 4, 5. Positive 2. Then we have negative 7. Positive 3. Then we have negative 8, positive 4. Then we have negative 8.5, 5. And negative 8.25. Did I do that right? That would be, negative 8.25 would be this way. Did I mess it up? And that would be 6, so that would be up here. I think that I did that one wrong, y'all. Hold on one second. Let me look at my key. Hold on, I'm going to pause you. Hey, I'm dumb. I just did the math wrong. It's going to be 7/5. Okay, so that would be 1/4. And then minus 9 is, let's make that a decimal. Math. Negative 8.75. Sorry, I'm dumb. So that would be closer. I was thinking it's got to get closer to negative 9, so that's why I was like confused. So here's my asymptote. It's going to make it curve, and this is going to continue to go in this direction. So this one's going down. Why? Well, our base is a fraction. Okay, so since that base is a fraction, we're seeing decay is what we're seeing. Now, our domain is all of the x's that are greater than, what's it approaching? Negative 9. Your domain is still going to go to negative infinity and positive infinity. As x approaches infinity, so that's this direction. As x is going this way, our graph is going down. So that's going to be negative infinity. Actually, I messed that one up. That's going to be on the bottom because we're going to negative infinity. So this one up here up top, so as y is going to positive infinity, that's this direction. This is where we're running into our asymptote. We are approaching negative 9. Okay, your x-intercept for this one, we didn't find that. We would have to continue going on to see that. So I don't want to actually take the time to do that. That's when you could just plug that into Desmos. So beautiful free math, Desmos. Start graphing. Sorry, I should have had this pulled up. Okay, so I'm typing in the log with a base. Remember that you have to go here. Nope, that's not how you do it. Let's see if I can remember actually how to do this. Functions, miscellaneous, log with a base, which is this one. So we need 1/2. This is the one that won't work. Oh, you know what? Let's just do 0.5. 0.5. That didn't work either. Okay, hold on. Type this back in. Functions, log with a base. We're going to put 0.5. Yes, you will work. Make it a fraction. Okay, and then x plus 9. Scroll out of that, and then that is going to be plus 4. Ta-da! Then you can see it's crossing the x-axis at 7, 0. Remember, if you want a table for this, you click here, get your table, and then you can see that we want to get down here to where this 2 is. Press enter, and then we should see 7 at some point. There we are, 7, 0. That is our y-intercept, so it's going to cross at 7, 0. Okay. Questions? Cool. All right, this last one is the same exact thing. I'm not going to work through it again. I know you are tired of listening to me already. You would start the process the same. I'm going to help you set your tables up. So we've got 5x to the y power. That would be your first table. You would do 5 to the negative 2, 5 to the negative 1, on and on and on to get that. Then you would switch that table to do your inverse. Once you have your inverse, then you would do your last table. This would be x plus 2. This would be y plus 1. That would give you the information to graph that. Okay, so there it is. I know you're probably thinking, like, can I just put it in Desmos? Sure, you can. But I do want you to be able to do this by hand so that you know how to do it without a calculator. I don't want you to always be dependent on a calculator. That's why I went through the process of showing you how to do this. I'm going to be specific on your homework assignment. Let me look at your homework assignment. I'm going to make you do some of them by hand. Pause. Okay, this is going to be your homework assignment that I'm going to give to you. You're going to do 4, 5, and 6. Now, you could use Desmos to help you, but I still want to see the tables. With this one, Desmos is not going to help you because I don't know how to enter that as a fraction. So unless you figure it out, I don't know. You're going to have to do this one by hand. So let me know if you need help when you get to this one. You're going to do 4, 5, and 6 for homework. You don't have to do number 7. Okay? All right. Let me know if you have questions. Remember, questions on Remind are easier for me to answer than on Google Classroom. I love you. I miss you.